Good afternoon, biology students. Just a quick recap of day 3 of enzymes. Today's focus was catalysts. And the question was, does all food break down in your stomach at the same rate? The answer is obviously no. Evidence in the paragraph is right here where it talks about some food being more difficult to digest. You must also consider that some food has sugars which break down quickly and some has more protein which breaks down much slower. Same is true for starch, breaks down quicker, fats break down slower. Next question is, what is a catalyst? Well, a catalyst is an enzyme that speeds up chemical reactions by lowering the amount of energy it takes to actually break down the food you're trying to get energy from. And knowing that an enzyme is a protein, and if a catalyst is a type of enzyme, the logic says that a catalyst must also be a protein, so yes. Next, what is the role of a catalyst? Again, I kind of touched on that already. It reduces the energy needed so your body can properly metabolize the food with less effort. Why is it important? Well, because it's not worth the cost and benefit. Think of the coyote chasing the rabbit. If the rabbit is too fast and hides, the coyote is going to say, forget you, I need to find me an easy catch. So an older or a much younger or a sick or injured rabbit, so it doesn't waste energy looking for food that won't give as much in return as it cost in the chase. Next, focusing on this, which ties into your liver lab. Your body works best under certain conditions. That's what we talked about as homeostasis. So when would the amount of enzyme and substrate have a decreased reaction rate? Well, that would be any time that temperature is too high or too low. So if you're running a fever or you're hypothermic, you would be much less inclined to properly digest food. Same is true if you have a sour stomach, too high of acid, right? When you have the flu, you lose an appetite because you have the wrong pH level. In combination, your body is usually running a fever when you're sick. Both of those are double whammies against properly digesting food, and that way the decreased reaction rate is due to temperatures that aren't ideal. Again, your body must be equilibrium, which we call homeostasis. So specifically the temperature, this is the ideal temperature. It's approximately 37 degrees. Now this is in Celsius, so don't think, when we think 37 degrees, we think 32 degrees is freezing, but that's Fahrenheit. 37 degrees is actually body temperature, which is 98.6. So to keep it familiar, keep a familiar temperature unit, 37 degrees, this is the same as 98.6. But we can see, if your body gets slightly cooler, we have less of a rate. But if it runs a fever, the rate decreases drastically. So it's very steep. Very steep curve says no good, no bueno for digestion. Lastly, same idea. Your stomach pH is just over 7. If it gets a little bit too much acidic, the rate slows down. And if it gets too much over 7.2 or so, the rate also slows down. So again, this is the normal body conditions that make digestion ideal. So match this up with the notes I left you in the modules, and you'll have all you need for this unit.